Hey, it's Mike from Arnold Tutoring. Here we have a pretty common Calculus 1 question where we're asked to find the intervals of increasing or decreasing over a certain function. A couple things to note there. Calculus is all about understanding rates of change, and that's why we find the first derivative like we've talked about in other videos. In this case, we actually want to know whether the first derivative is positive or negative. And if you think about that in terms of like a car, let's say, if the rate of change of a car is positive, that means that its speed is positive and the position is then increasing. In other words, the position from where you started, you've moved forward. Vice versa, if your rate of change is negative, that means your speed is negative and your position is decreasing, or you're going back to where you started. And so whenever we see increasing or decreasing, we want those to be trigger words in Calculus 1 for finding the first derivative and determining the sign of the first derivative. So I'm just going to write those notes up here. We know that when f prime of x is greater than 0, so when the first derivative is positive, that means our function is increasing. Same thing on the other side. If the first derivative is less than 0, that means our function is decreasing. And these are absolutely crucial in Calculus 1, especially when we get into curve sketching or other word problems where they're sort of hiding this increasing, decreasing part in the question, but we still need to find those intervals. So what are we going to do? As soon as we see those, I'm going to find the first derivative. The first derivative, I'm going to bring the 3 down, so we get 3x squared plus the 2 comes down and cancels with the 2 on the bottom, so I'm just left with 11x minus 4, and plus 9, the derivative of plus 9 is 0. So this is a quadratic. Because I want to know where it's greater than 0 and where it's less than 0, I first want to set it equal to 0. And then we can test on either side of those points where it equals 0 to determine where it's positive and where it's negative. So I'm just going to set the first derivative to 0. And whenever we have a quadratic equal to 0, we can either use the quadratic formula or factor. So I'm just going to go ahead and factor. Looks like this factors nicely into 3x and x. I need my last 2 numbers to multiply to negative 4 and multiply that, or add to positive 11 when they're multiplied to the 3 and the 1. So I can see that I'm going to have plus 4 here and minus 1 here. That'll get me 12x minus 1x, which is 11x. So from here I can tell that my answers to set the first derivative to 0, or where the first derivative is 0 on my function, is when x equals 1/3 and when x equals negative 4. Those are the points where it equals 0, but we actually don't want those in our interval. We want the spots where the function is increasing or decreasing. Remember, where the first derivative is 0, that means the function is flat, neither increasing nor decreasing. So what I'm going to do is I'm going to just do a little number line here, and I'm going to put those 2 points, 1/3 and negative 4, I'm going to put those on my number line. And what I'm going to do is I'm going to write a 0 over top of here, indicating what the first derivative is at those points. Now, I'm going to test, in my first derivative, I'm going to test numbers in the gaps here on my number line. Because if it equals 0 at these points, that means it's either positive or negative on the intervals around them, and that will get us where we want. So the first derivative, if I plug in negative 10, let's say, any number less than negative 4, I'm going to get a negative times a negative, which is a positive. So I don't even care about the value, I just care about whether it's positive or negative. What if I plug in a number between negative 4 and 1/3? Let's say 0. I'm going to plug 0 in here, and I'll get a negative in this bracket, but a positive in this bracket. Negative times a positive is a negative. That means in the interval between negative 4 and 1/3 for x values, our first derivative is negative. Last interval, I'm going to plug in positive 10. I get a positive times a positive, which is a positive. So you're picking x, these are the x values here. You're plugging in values from the interval into f prime of x, and then we say, well, what does that tell us about f of x? A positive first derivative means f of x is increasing. So I like to draw arrows like that because increasing for a curve means it's moving up and to the right. Decreasing means down and to the right, and positive means increasing. Therefore, our increasing intervals, just to wrap up the question, when they say intervals, we want to list the x coordinates, or the x values over which it's increasing. So I know it's anywhere less than -4 and anywhere greater than 1/3. So I'm going to say -infinity to -4, union with 1/3 to infinity. And notice the round brackets around -4 and 1/3, because at -4 and 1/3, the first derivative is 0. It's not positive or negative. Vice versa, the decreasing is where the first derivative is negative, and that happens between -4 and 1/3. So that is our final answer there, where we listed the intervals over which this function f of x is increasing and decreasing. Again, to do that, we figured out the first derivative, found out the intervals around the points that made the first derivative 0, and we tested whether those intervals made the first derivative positive or negative, which corresponded to increasing or decreasing. Hopefully that was helpful. All increasing, decreasing questions in calculus require the first derivative and a method similar to this. So go try some other questions on your own. You can always email us more questions, info@arnoldtutoring.com. Thanks.